All right, now let's talk about transforming quadratic functions. Okay, so the typical normal quadratic function starts at 0, so if it's just x squared, I'll graph it in blue. It'll go left to right 1, up 2, up 4, 3 to 9, so something like that, or like right here, and so on. So it'll be just like this. So now, if we have minus 3 or plus 3, the graph will shift. And like let's say for x minus 3, the new graph will shift to the right 3 units. So go from 0 to 3, the vertex. So then once you find the vertex, up left to right 1, up 1, left to right 2, up 4, 1, 2, 3, 4. And this one will be like right here. And the graph will just shift to be like that. If we're going x plus 3, here I'll do it in this color, it's going to go to the right. So, or sorry, the left. So if we go here, left to right, 1, up 1, left to right 2, up 4, and like so on. So the key point is like basically if you're going, if it's like x plus something, you're going to go to the left. And then if it's like x minus something, you're going to go to the right. Okay, and then if it's like x squared plus 3 or x squared minus 3, then that's going to take the graph and you're going to go up or down. So for plus 3, the vertex would now be here, 2 to 4, and the quadratic would be moved up like that. If it's minus 3, then the vertex would be here, and then we would continue graphing just something like this. So the minus 3 moved the original function, which would be here, basically up or down, and all the points got moved, right? But one easy way to do it is start at the vertex, go left or right, 1 or 2 or whatever, and then do the transformation. Okay, now let's talk about stretches and some of the reflections. So if we have, say, 2x squared, so I'll graph the original function, y equals x squared, and then I'll show the transformation. So that's the original. So now I'll graph the other one in blue. We're going to go, if we start at the origin, because it's still going to be 0, 0 for the vertex. When we go left to right 1, we're going to go up 2. And then when we go left to right 2, we are going to go up 8. So all of the points basically get multiplied by 2. And you can always make a table of values and plug points in, but the method of using the vertex and then just doing the transformation that way is usually easier. So that's that one. And then if it's 1/2 x squared, then I'll do it in the purple, the pink. So then all the points will basically be like compressed. So 1, 1 would be now like a half instead. And then if we go left to right 2, we would normally go up 4. This time we would only go up 2. And then 9 for like left to right 3, up 9 would become left to right 3, up only 4.5. So roughly something like right here. And then connect the dots. Okay, good. And then if we have a negative x squared, here I'll do that one in white. So that's going to be a reflection over. So like for example, negative x squared would be like this. So negative 2x squared would now be left to right 1, down 2, because normally we would go left to right 1, up 1, but since it's negative 2, it would be reflected. And we would go down instead of up, and then stretch of 2. So we would go down 2 instead of 1. And then 4 would become, or left to right 2 would now be down 8. So 1, 2, 3, 4, 5, 6, 7, 8. And that is how this one would look. Okay, now let's do it verbally, or like with the instructions. So with x squared, we want to go right 4. So I'm going to make the equation like this. So right 4 would mean that it's x minus 4 squared. Vertical compression by 1.5. So that's adding 1.5. We are going down 10, so minus 10, and then reflect in the y-axis. So the y-axis is this one, and we're doing a reflection over it, so there's a negative out in front. So if we take our original graph, I always like drawing the original and then doing the transformations. It usually is a little bit easier. And then 1, 2, 3, 4, 5, something like that. So let's do the negative 1/2 part first. So that's, I'm going to do it in the blue. So that's going to mean that 0, 0 stays the same because that's not affected, so our origin is there. And then now all of the points basically get divided by 5. So that's going to be like 4/8. And then 9 is going to be like basically around 2. And like so on. So then it's going to be like a very narrow quadratic, roughly like that. And then it's going to be shifted to the right 4 and then down 10. So we're going to take this blue graph, and then we're going to go right 4, and then down 10. So 1, 2, 3, 4, 5, 6, 7, 9, 10. So here, and then just kind of draw the best you can. So that would be our function.